Hi, welcome to this session on Construct a control circuit for the control of a double-acting pneumatic cylinder with momentary input signals. By the end of this session, you will be able to know the working principle of the double-acting cylinder and 5-port 2-position valve and to assemble the circuit on the trainer board and check the function of the circuit. The double-acting cylinder is an actuator that can push and pull the load using compressed air. Let's now see the main parts of the double-acting cylinder. The double-acting cylinder has two ports for air supply. The input ports supply air. The piston moves to and fro inside the cylinder. The cylinder confines air for the piston movement. The piston rod connects the piston and a load. The piston seal prevents leakage across the piston. The rod seal prevents air leakage from the cylinder to the atmosphere. The piston end is the part of the cylinder consisting of air passage and connected to the piston side. The rod end is the part of the cylinder consisting of air passage and connected to the piston rod side. You know the main parts of the double-acting cylinder. Let's now see how it works. When air is supplied through port A, force is exerted on the piston so that it moves in the forward direction. This movement is called forward stroke. During the forward stroke, air already present at the rod side exhausts through port B. Piston movement will stop if the air does not exhaust. When air is supplied through port B, the air already present exhausts through port A and the piston retracts. Displayed on the screen is the symbol of double-acting cylinder. To control single-acting cylinder, or in other words, to push and pull load by single-acting cylinder, you always need 3-port 2-position direction control valve as the main control element. To operate double-acting cylinder, the direction of air between ports A and B need to be changed. Therefore, a valve is required which has two output ports. 5-port 2-position valve has two output ports and its construction is shown here. Let's now see the main parts of 3-port 2-position valve. It consists of a valve body, spool, input port, output port and exhaust port. The valve body provides cavity to move spool and ports. The spool is an element which changes flow path when moves inside the valve body. The input port where air enters into valve. It is denoted by P. The output port where air comes out of valve. Output ports are denoted by A and B. The exhaust port where air exhausts. Exhaust ports are denoted by R and S. The arrow position refers to Status of direction of airflow path in the valve. In one position, port P is connected to B and port A exhausts through R, but exhaust port S closed. In other position, port P is connected to A and port B exhausts through S, but exhaust port R is closed. Take a look at the symbol of 5-port 2-position valve. You know the main parts of the 5-port 2-position valve. Let's now see how it works. Here is the circuit to operate double-acting cylinder. Initially, the circuit is in normal position, that is, the spring-operated position. Supply direction is from P to B and A to R, so that piston is always in retracted position unless actuated. When push button is operated, airflow path changes inside the valve so that supply direction is P to A and B to S, thus causes piston to move forward. When the button is pushed and deactivated, the piston retracts. Let's now see the tools and materials required to operate the single-acting cylinder using a 5-port 2-position valve. It includes the trainer board, pneumatic source, compressor, PU tube, FRL unit, 5-port 2-way valve and single-acting cylinder. To operate the double-acting cylinder using a 5-port 2-position valve, you need to first arrange the components on the trainer board. For example, arrange the pneumatic source, 5-port 2-position valve and FRL. Take a look at the ISO 1219 symbols for the components displayed here. Here is the circuit diagram to operate the single-acting cylinder using a 5-port 2-position valve. Initially, the circuit is in normal position, that is, the spring-operated position. Supply direction is from P to B and A to R, so that piston is always in retracted position unless actuated. When push button is operated, airflow path changes inside the valve so that supply direction is P to A and B to S, thus causes piston to move forward. When the button is pushed and deactivated, the piston retracts. Now, let's see how to arrange the components as shown in the circuit diagram. First, arrange the component on the trainer board. Then, connect the source to FRL and FRL to input port 1 of 5-port 2-position valve. Next, connect output port 2 and 4 of 5-port 2-position valve to input port A and B of double-acting cylinder. Ensure the connections are proper and supply air. Make sure if there are no air leaks in the joints. Now, to check the function of the circuit, first you need to press the push button. When you press the push button, the piston should move forward. Next, release the push button. When you release the push button, the piston retracts. By pressing and releasing the push buttons, you can check the piston movement and thereby draw a conclusion that the motion of the double-acting cylinder can be controlled by a 5-port 2-position valve. We have reached the end of this session on construct a control circuit for the control of a double acting pneumatic cylinder with momentary input signals. You should now be able to know the working principle of the double acting cylinder and 5-port 2-position valve and to assemble the circuit on the trainer board and check the function of the circuit.